This illustration deals with equipment disconnects in accordance with NEC 230.85 items 1 through 3. Purpose of change is to provide a new section, and this new section has been added to recognize the need for an outdoor disconnect for first responders. These requirements are practical, feasible, and mainly to provide installers and with multiple options. Today, first responders and utility personnel do not have a way to safely remove power from a structure unless there is a means to disconnect the electrical, I should say the electric utility supply that is located outside of a structure in a readily accessible location. In other words, they have to jerk the meter, and that kind of creates a problem for the users of the power sources that the utility provides. So kind of looking and reviewing what this is all about, and you know, in previous illustrations, I told you to be sure and look at 230.85 very carefully where other sources were involved. So first, we're looking at this PV system up at the left, and it's mounted on a roof or ground. We look where it's mounted on a pole or on the ground, and notice it's fed into a disconnect, and then may even have a disconnect down here to the inverter, which takes the DC and converts it into AC. And then we may even have a battery system that would feed in. It depends on the systems that you might have there. And notice you need an equipment disconnect. Now, emergency disconnect and not equipment by 230.85 number 2. If you do not fuse a disconnect, then usually it is not considered like, well, for instance, look at the meter disconnect up here to the left of the service equipment where the meter is. If you don't fuse that disconnect, usually the inspectors say, well, that's just a disconnect for the utility. But you have to talk to the inspection department to see how they rate that. Would they like it to be fused, or it's just a non-fusible disconnect that they can open and then service the meter or whatever, or first responder, coming in where there's a fire or something, could disconnect the power. But if they find they need the power, that circuit didn't necessarily need to be disconnected, that's involved, then they could just turn the main source of power back on. Then you terminate into a main that is shown there. Then this would be a dwelling unit type panel board with the grounded neutral conductor coming in. And then the emergency disconnect that we're talking about here in the equipment disconnect area in accordance with 230.85 items number 1 is kind of discussed in the notes. So looking at note 1, disconnect shall comply with 110.21B with its field markings or marked from the manufacturer in the NEC, labeling and markings. So we go to 110.21B to see how these disconnects would have to be marked based upon what are they disconnecting. Now, information note 2 says service disconnecting means shall have a short circuit rating, and there that again say equal to or greater than the available short circuit current that's been calculated. Now we would look at 230.85. 110.9 deals with terminal ratings that you're not supposed to have the amount of short circuit current that could damage them or even in some cases blow them apart. And then 110.10 says, hey, you can use anything, bus bars, conductors, anything to lower the short circuit current from the transformer to this point, 110.10. And then another big item is listed 110.10 that I feel is very important. It does say that you might have some minor damage here. Say, for example, the short circuit current damaged a breaker, but you could replace it. Then 110.10 says that's minor damage, but if it blew the equipment up, because we'd have to completely change it out, then that's naturally you haven't designed it right. Then 110.24 says that the service only, you have to calculate the available short circuit current, and that rule came into the 2017 edition of the NEC. Now, that kind of wraps up what we're talking about here, where these disconnects are required by NEC. But remember, when you deal with PV systems and you deal with wind generators or electrical wind systems, you better check with the authority having jurisdiction, because they may require more disconnects than what the NEC might require. So you putting these systems in for the first time, I would check with the authority to see locations of disconnects, if they're strictly according to the NEC, or do they have an ordinance that might require additional disconnects. So make sure you check that out.